Unit 7, Day 2, Special Right Triangles. We're going to talk about two types of special right triangles today. The first one is the 45, 45, 90 triangle. That's when you have a triangle with angle measures 45 degrees, 45, and 90. The isosceles triangles theorem tells us that if you have two congruent angles, then the sides that are opposite from them are also going to be congruent. So this leg and this leg are congruent. This side, the hypotenuse, in order to find that one, if you go from the leg to the hypotenuse, we're going to multiply by the square root of 2. So here you have leg times the square root of 2 equals the hypotenuse. Now if you wanted to go backwards, if you have the hypotenuse and you need to find the leg, then we would just do the inverse operation. Take the hypotenuse, divide by the square root of 2 to get the leg. Now let's do a couple examples. In this very first one, again, here's our two angles, and so we have this side is congruent to that one, and then we're given a leg, so the leg times the square root of 2 equals the hypotenuse. So our leg is 10, so we have 10 times the square root of 2 equals the hypotenuse, and since we can't simplify this anymore, 10 square root of 2 is the length of our hypotenuse. And then what we knew from the beginning is that these two legs are exactly the same length. Now let's take a look at this next example. Here are our two congruent angles, so that means x and y are going to be the same. And we're given the length of the hypotenuse. So our formula with the hypotenuse says that the hypotenuse divided by the square root of 2 gives us the leg. When we substitute in our value, the hypotenuse is 7 times the square root of 2, and we want to divide that by the square root of 2 to get the leg. Square root of 2 divided by square root of 2 cancels out to 1, so we're left with 7 is equal to the leg. So that's this leg and this one, since they're both going to be the same. The next triangle we have is the 30, 60, 90 triangle. So this has angle measures 30 degrees, 60 degrees, and 90 degrees. Now, this 90-degree angle is of course opposite from the hypotenuse. This is our longest side. Now we have this leg and this leg. Between the two legs, we just want to decide which one is going to be the shorter leg and which one's the longer leg. So from this one, opposite is 30 degrees. From this leg, opposite is 60 degrees. Since the 30 degrees is smaller than the 60, we're going to say that this one is the short leg and this one is the long leg. Now, given those measurements, we want to talk about the ratios of the side lengths. Everything in this triangle is based off of the short leg. It's a little more complex than the 45, 45, 90, so make sure you pay attention. If you have the short leg, in order to get the hypotenuse, you're going to multiply by 2. So the short leg times 2 gives you the hypotenuse. Now, if we were to go backwards, again, given the hypotenuse, the way you find the short leg is to do the inverse. Hypotenuse divided by 2 gives you the short leg. Now if we want to talk about the long leg, again, we have to go from the short leg. The short leg to the long leg, you have to multiply by square root of 3. So the short leg times the square root of 3 gives you the long leg. Now if we go backwards, from the long leg to the short leg, again, the inverse operation, long leg divided by the square root of 3 will give us the short leg. Now, if you look at these four equations carefully, you'll notice that there's nothing that takes you directly from the hypotenuse to the long leg or from the long leg to the hypotenuse. And that's because you can't. It always has to be a two-step process. You're always going to have to find the short leg first in order to find the other piece of information you're looking for. So let's work out a couple examples. First, let's label the sides. This one's our short leg because it's opposite from the 30 degrees. This one's going to be our long leg, and of course this is our hypotenuse. So we start off with the given short leg. The short leg times 2 gives us the hypotenuse. So we're going to take the short leg times 2 to give us our hypotenuse. Our hypotenuse is going to be 8. Then we want to take a look at the long leg. the short leg times the square root of 3 gives us the long leg. So our short leg is 4 times the square root of 3, and you can't simplify this anymore, so 4 times the square root of 3 is your final answer for the long leg. This is the easiest scenario when you're given the short leg. Take a look at this one. This is the hypotenuse. 60, this one's opposite, the long leg, so that means this one has to be our short leg. We're given the hypotenuse. So when you start off with the hypotenuse, you have to find the short leg first. Hypotenuse divided by 2 gives us the short leg. Our hypotenuse is 12, so 12 divided by 2 gives us the short leg, which is 6. Then we can use that short leg to find the long leg just like we did in the first example. Short leg times the square root of 3 equals the long leg. So the short leg, I was supposed to substitute that value. Our short leg that we found is 6 times the square root of 3 equals the long leg. So again, you can't simplify this, so our final answer is 6 square root of 3 equals the long leg. When we look at this last example, here, this is the hypotenuse. Across from the 30, this is the short leg, so that means this one must be the long leg. We're given the long leg, so again, in order to find these two side lengths, you have to find the short leg first. The long leg divided by the square root of 3 gives you the short leg. So the long leg is 5 root 3, and when we divide that by the square root of 3 to get the short leg, square root of 3 divided by square root of 3 cancels out, so you're left with 5 is equal to the short leg. Now we're going to use that short leg to find the hypotenuse, just like we did in the first part of the first example. So the short leg times 2 gives us the hypotenuse. So the short leg is 5 times 2 gives us the hypotenuse, which is 10. Now these are the easier examples, just like the examples we did with the 45, 45, 90. Before we do some more complicated examples, we're going to need to do a little bit of algebra review. So in order to review our algebra, we're going to go over these two things about radicals. The first, the product of two radicals is equal to the radical of the product. What that means is if you're multiplying two radicals, that's the same as taking the radical of the two numbers multiplied. So there are two ways that we can evaluate this. The square root of 2 times 2 is equal to the square root of 4, which most of you have memorized is equal to 2. The other way is if you take a look at this the way that we've been simplifying radicals, these two will pair up, one of them gets out, one of them doesn't make it, and then this is our final answer. Either way, we end up with 2. Now the square root of 2 times the square root of 2 equals 2. So here, it's similar, but we have this first term has a number outside the radical. Numbers outside the radical can multiply, and numbers inside the radical can multiply, but you can't multiply them together if they're not both outside or both inside. So here the only thing we can do is that 5 stays, but we can multiply these two. So we get 3 times 3. And again, we run into this dilemma of 3 times 3. Now you can evaluate it both ways, but we know that the square root of 3 times the square root of 3 is going to equal 3. So we end up with 5 times 3, and our final answer is going to be 15. A couple other things. Radicals cannot remain in the denominator. And denominator, that's the bottom of the fraction, remember. You have to rationalize and simplify all radicals. Okay. So if you notice here, we started off with this problem, square root of 2 times the square root of 2, and then our final answer was positive 2 with no radical. We're going to take that idea to get rid of this in the denominator. So if you multiply the bottom by the square root of 2, then square root of 2 times the square root of 2 is 2. But you can't just multiply the bottom of the fraction, or else it changes the value. So you have to multiply it by the top. This way, this is a fancy looking 1 that we're multiplying by this fraction. So 6 times the square root of 2 is just 6 times the square root of 2. The very last step that we have is you want to look at the numbers outside of the radical and see if you can simplify it. So 6 divided by 2 is 3. That square root of 2 on the top doesn't go away, so this is your final answer. Now when you take a look at this one, same idea. We want to multiply the top and the bottom by this fancy 1, but it needs to be the same as what's on the bottom here, so that the square root of 3 times the square root of 3 gives us 3, and then on the top we have 4 times the square root of 3. So we're going to take a look at simplifying again. 4 divided by 3 is going to give us a decimal, and you don't want that. So since you cannot simplify this, we're just going to leave it 4 times the square root of 3 over 3 as your final answer. It's okay to have fractions as your final answer as long as there are no radicals in the denominator. So let's work out a couple more examples. In this one, we have a 45, 45, 90. So remember with those, these sides are going to be the same length. In this one, opposite from the right angle, here's our hypotenuse. So when you look at your 45, 45, 90 triangle, we have the equation that the hypotenuse divided by the square root of 2 is equal to the legs. Now, when we take that 12 and substitute that in for the hypotenuse, we end up with this radical in the denominator. So to get rid of it, we want to multiply by the square root of 2, and then we have 12 times the square root of 2 on the top, and then we have 2 on the bottom. And again, to simplify, look at 12 divided by 2, and then we're going to get 6 times the square root of 2 as our final answer. So this leg is 6 root 2, and this leg is 6 root 2. Now, when you take a look at this one, let's label. This is going to be a 60, 90, this one needs to be 30 degrees. So this one's going to be our short leg, this one's going to be our long leg, and then this one is going to be our hypotenuse. We're given the hypotenuse first, and remember, you have to find the short leg first in order to find the other one. So we'll start off with our equation that says the hypotenuse divided by 2 gives us the short leg. So let's substitute in our values. Our hypotenuse is 6 square root of 3 divided by 2 gives us the short leg. So the only thing we can do here is simplify that. 6 divided by 2 is 3 times the square root of 3 is our short leg. Now we're going to use that short leg to find the long leg. Our formula says that the short leg times the square root of 3 gives us the long leg. So when we substitute in our values, our short leg is going to be 3 root 3 times the square root of 3 to give us the long leg. Now 3 is the only number outside the radical. Square root of 3 times the square root of 3 gives us positive 3. So our last step, 3 times 3 is 9 for the long leg. Now we're going to stop there. We'll work out some more example problems and word problems in class.